right, Chapter 3, Jamboree. I'm going to go through a bunch of problems here in Chapter 3, take them step by step. I might move quick, but just pause when you get, when I'm moving too quick, rewind it a little bit and play it again. Here we go. I'm going to talk about some of the approaches. The main approach, things we're going to do here is we're going to get rid of parentheses, we're going to get rid of a few things. We don't want parentheses. We're going to get rid of those. We want to try to get rid of fractions. We want to try to get rid of decimals. We want to try to get rid of mixed numbers. We basically want to get it down to a problem that's all integers, meaning all whole numbers, positive and negative, so that it's easy to solve. So that's what we're going to do. I'm going to approach this guy like that. I notice right off the bat I see a mixed number here. I don't like that. And I want to somehow get that to an integer. But there's a step I have to get in the middle. First I'm going to change it to an improper fraction. 2.5. Now a lot of people just go right up and say 2 times 2 is 4 plus 1 is 5 over 2, which is right. It is 5 halves. But here's what you actually did. You actually know that 2.5 is the same thing as 2 plus 1 half, which is the same thing as 2 over 1 plus 1 over 2, which is the same thing as 4 over 2 plus 1 over 2, which is the same thing as 5 halves. So when you do that multiply this times this, and you get the 4, that 2 times 2, that 4 you get before you add it to the 1 is 4 halves. So it's not magic. When you're going to change 5 and 2/3, and you say, oh, 5 times 3 is 15 plus 2 is 17 over 3. I think that's great. But remember, that 5 times 3, that 15, you actually is 15 thirds. And then you added 2 more thirds, and you got your 17 thirds. So just be aware of what you're doing. So I'm going to walk up. I'm going to change this to 5 halves because I like improper fractions better than mixed, but I'm still going to see, wait a minute, I still am not a big fan of fractions, so to undo those fractions, I'm going to do this sweeping trick. I know that this is an equation, which means it's balanced right now. This equals this. This weighs the same amount as this. So if I double this side and double this side, it's still equal. That's what I'm going to do. I'm going to multiply both sides by something. What, you ask? The LCD of the entire thing. So I look at all my denominators, 3, 2, 3, 6, and 2, and they all go into 6. They're all factors of 6, so I'm going to multiply both sides of this equation by 6. And watch what happens. It's like magic. Watch. It's unbelievable. Now, I'm going to just multiply 6 times 2/3. Watch. 6 times 2/3 is the same thing as 6 over 1 times 2 over 3 equals 12 over 3, which equals 4. 4x. Right? 6 times 1/2 is just half of 6. We know that's 3. Right? X. And minus 1/3 of 6 is 2. Now, the way you can actually go about these problems, what I'm talking about right here, is you can either do 6 times 2 is 12 divided by 3, or you can do 6 divided by 3 is 2 times 2, which is 4. I usually approach it that way. I do the division first. 2 times 2 is 4. That's usually the way I do it. So over here, I'm going to show you that way. 6 divided by 6 is 1. The 6's cancel out. I get 5x. Minus 6 divided by 2 is 3 times 5 is 15. Now look what happened here. I had a mixed number, changed it to an improper, got rid of all the fractions by multiplying both sides by the LCD. I have a nice problem with integer coefficients. I'm excited. I know I'm almost there. 4x and 3x combining like terms, 7x minus 2 equals 5x minus 15. Now I want all the x's on one side. Well, let's get rid of the x's on this side because I don't like them over there. I want them over here. Here we go. Look at that. Now there's no x's left on this side. Minus 15 minus 2, 7x and 5x is 12x. I'm going to add 2 to both sides. Add 2 to both sides. What do I end up with? 12x equals negative 15 and 2 is negative 13. Did I make a mistake here? 7x, 5x, 12x. Oh, yes, minus 5x. That should be 2x. Oh, my goodness. 2x, so I should end up with 2x there equals negative 13. 2, 2, and I get my x equals negative 13 halves. Well, what is this saying? This is the division problem, right? So how many 2's go into 13? Well, 1 through 3, 6 of them. 6 whole amounts. 6 whole 2's go in. 6 times 2 is 12. 13 minus 12 is 1. 1 what, you ask? Not remainder of 1. One of those babies. 1/2. 6 and 1/2. Don't forget, negative 13 halves will translate into negative 6.5. Watch that negative sign. All right, so here, what did I do wrong? Notice I forgot to subtract from. I just wrote 5x down there. Sloppy. Oh, my goodness. Woo-hoo-hoo. Next problem. Here we go. Ah, what is this thing? It's a repeating decimal. Well, let's see. Here's my little hint for you. I know that 0.4 is the same thing as 4/10. I know 0.4 repeating is 4/9. So what do you think this 0.3 repeating is? Yes, it's 3/9, which reduces to 1/3. So I'm going to change this to 1 over 3 so I can get this problem, do this problem. Now, Word to the wise, help you out here. Do not go in and multiply both sides yet. When you have fractions inside the parentheses. For now, until you get accustomed to it, distribute. Get rid of the parentheses first, then do the sweeping motion by distributing both sides by the LCD. So I'm going to distribute first here. 3 times 1 is 3. 4 times 2 is 8. X minus 3 times 3 is 9 over 4. Now I'm going to distribute a negative 1/3. Negative 1/3 times 1/2 is going to be negative 1 over 6x. And then negative times a positive is going to be a negative 1. I get 4 over 3 equals 1/2. Now another thing you could do, you could just distribute this 1/3 through and get just the 1/6 and then the 4/3 and then realize you're taking the opposite of that. That's why you get the opposite of 1/6 and the opposite of 4/3. Whatever. Any way you like to do it that way. Now, can I combine like terms? Yes, we have all these things. Instead of changing all these fractions, we're going to go through, sweep them out, sweep out the fractions. Let's get rid of them by multiplying both sides by the LC dizzle. Here it's 24. 24, and watch how I'm going to go through. I'm going to do this division problem, 24 over 8 first. 24 over 8 is 3. 3 times 3 is 9x, minus 24 over 4 is 6, times 9 is 54, minus 24 over 6 is 4, times 1 is 4x. 24 divided by 3, 24 over 3 is 8, times 4 is 32. 24 over 2 is 12, times 1 is 12. All right, now we have all integers. Nice, that's what I like. Integer coefficients. Coefficient is just the number in front of the x, and all integer constants. So let's start combining like terms. CLT, right? 9 and negative 4 is 5x. Negative 54 and negative 32 is negative 86. 12, oh, almost there. Let's add 86 to both sides. What do I get? Don? 5x of 98. Divide both sides by 5. I get my x equals, let's see, how many 5s fit into 98? Well, how many 5s fit into 90? Well, I know that at least 10, but we'll put a 1 here. 1 times 5 is 5. 9 minus 5 is, yes, 4. 8. 9 goes for 8. 9. 5 goes for 8. 9 times 9 times 5 is 45. Remainder of 3. 3 what's, you ask? 3 of those, baby. 3/5. Whoops, I wrote a 4, and I was thinking 5. 3/5. So the answer is 19 3/5. Very nice, very nice. Here we go. And I think we have time for at least one more problem. Let me just double check the clock. Oh yeah, we've got all day. Here we go. All right, so, ooh, I see one of these guys. I'm going to change this right away to 5/2. I don't like mixed numbers. I'm going to distribute first before I get rid of all my fractions. So I'm going to do 3/4 x. Now I'm going to do negative 4 times 1/2. Or I could do this. Ready? Cover this up. Do 4 times 1/2 is, yes, half of 4 is 2x and 12. And then see what I want. This was positive and positive, but I want the opposite of them both. Negative, negative. Or I could do negative times a positive is negative, negative times a positive is a negative. Whoa! Crazy man. Knocked it over. Is that all set? Let me see. Alright, sorry about that. Alright, here we go. 5/2, I get 5/2 x minus 5 times 3 is 15. 15 over 2. Here we go. Now, I've got some fractions here. I get a 2 and a 4. They all go into 4, so let's multiply both sides by 4. Multiply this side by 4. What do I get? 4 divided by 4 is? Yes, 3x minus 4 times 2 is 8x minus 48 equals 4 divided by 2 is 2, 10x minus 30. Now I have all integer coefficients, so what am I going to do? Combine like terms. 3x minus 8x is negative 5x minus 48 equals 10x minus 30. Now I want to get all the x's on one side. What side? Doesn't matter. Let's bring it all over here. Negative 10x both sides. Get negative 15x minus 48 is negative 30. Let's add 48 to both sides. Because now I have my x's over here. I want to get rid of the constant, so now there's just an x, and then I'm going to peel off this 15, so there's only x alone over here. So let's see how it goes. I'm adding 48 to both sides. I get 18 equals negative 15x. Divide both sides by negative 15. Negatives cancel out. I get x equals 18 over negative 15. So now the answer is going to be negative. But how many 15s do go into 18? Let's see. 15 fits in 18 once. Remainder of 3. 3 what's? 3/15ths, man. Oh, can I reduce that 3/15ths? What goes into both of them? 5. Oh, I mean, I'm sorry, 3. 1/5. All right. So the answer is negative 1 and 1/5. You got that right. Give yourself a pat on the back. Great job. We're going to continue doing some more in a moment at Chapter 3 Jamboree, Part 2.